So this is expert TA number 5, problem 7. A baseball of mass 0.57 kilograms is spun vertically on a massless string of length 0.82 meters. The string can only support a tension max of 11.2 newtons. So here we have our free body diagram with tension, and that tension the max is 11.2 newtons, and we have that there. And part A is looking for what is the maximum possible speed of the ball on the top in meters per second. So the sum of the forces equals mass times acceleration. And here you can see at the top, the sum of the forces are both going the same way. So we have mg plus tension equals m times v squared divided by r, because it's going in a circle. So we're going to use the centripetal acceleration, which is equal to m times v squared divided by r. Now, using this, we can fill some stuff in. We know that the mass is 0.57 and the tension is 11.2, so we can get 11.2 plus 0.57 times 9.8 is equal to 0.57 times velocity squared divided by 0.82, and we got that from our length of the string. Now, with some math, we can get that, sorry, I can't see what I'm writing right now. But we get that 16.786 equals 0.57 times the velocity squared divided by 0.82. And if we divide that by 0.57, we get 29.4491 is equal to velocity squared divided by 0.82. Multiplying that by 0.82, we get 24.148 is equal to the velocity squared. And this was all done on a calculator before, so that's why it's going so quick. And now that we have the velocity squared, we can take the square root and find the velocity, which is equal to 4.9141. And that is the maximum possible speed of the ball at the top in meters per second. Now we are going to, for part B, find what is the maximum possible speed of the ball at the bottom of the loop. So we've got another diagram, but as you can see in this one, tension and mg are going in opposite directions because now the ball is at the bottom. So we have the sum of the forces again is equal to mass times acceleration, and we're using the centripetal acceleration because it's going in circular motion. So we have, well, actually, also, as you can see, they're going opposite directions, so the sum of the forces this time is t minus mg instead of plus, and then we have m times v squared divided by r. So now we have the tension, the max tension, 11.2 minus mg minus 0.57 times 9.8 is equal to the mass 0.57 times velocity squared divided by 0.82. The only difference of this is we're subtracting mg from tension instead of adding it. So we have 11.2 minus mg is 5.614, and that is equal to 0.57 times velocity squared divided by 0.82. So we take that 0.57 divided by 5.614 to get 9.849. is equal to velocity squared divided by 0.82. And to isolate it, we're going to multiply the left side by the right side. So we have 8.07628 is equal to velocity squared, and we're going to take the square root of that and get velocity is equal to 2.8418. And now we have our velocity for the bottom and for the top. And as you can see, they are different. That's because at the top, we have mg and tension working in the same direction. So we have a much higher force. With a much higher force, we're going to have a much higher velocity. And now at the bottom, we have tension and mg working in opposite directions, giving us a much smaller force with a much smaller velocity. You can compare the two of them in the equations.